Hello, welcome back. We're going to do rotations today. For this, a lot of people have a hard time seeing rotations, so I'll try to give you a couple different tools to use in being able to do them. This is section 4.8 and 9.4. A rotation is a transformation that turns a figure about a fixed point. The center of rotation is the point on which a figure rotates. You also have to understand clockwise and counterclockwise, since a lot of our watches are digital and stuff. So clockwise means that we are starting, and we're starting in this way, and we're going in this direction, where counterclockwise says we're starting in this direction and going in the opposite way. So you need to make sure that you pay attention to whether they want it to be clockwise or counterclockwise. In case you see the abbreviations, clockwise is abbreviated with CW and counterclockwise is abbreviated with CCW. Okay, we're going to talk about two types of rotations, a 90 degrees clockwise and a 60 degrees counterclockwise. Help you understand the rotation. First of all, the blue one is my pre-image and the red one is my image. So I'm going 90 degrees in this direction. And that means if I take any point, like they chose this point on the figure and the corresponding part over here, and I drew in from there to the origin, it was not a very straight line, there we go, that is a 90-degree angle. So I can take any point and its corresponding point, connect them to the origin, and that angle is a degree measurement. So like if I went from this point to the origin and the corresponding part to the origin, that would be my 90-degree angle. Same thing over here with a 60-degree angle. This is a 60-degree angle. They did the same one. They took that last point and connected it there. Let me try to draw a straighter line. There we go. And that angle right there is a 60-degree angle. Same thing again. I could take any of the points and connect from one corresponding point to the center of rotation and from the other one. We're going to look about the origin, although it could move off of the origin. It could be somewhere else, but we're only going to focus on the origin one. Okay, I'm going to pause the video right now and plot my A, B, C, and D on both of my graphs. You do the same. Okay, so I plotted A, B, and I plotted C, D on both graphs. So on the very first graph, remember, if they have the same angle measurements, when I connect one corresponding to the origin and the other one, so A and C were my corresponding, so I'm going to draw a line from A to the origin and from C to the origin. That looks like a 90-degree angle for me, but I really don't have to go by looks. I could look at the slope. The slope from A to the origin is up 1/3, so its slope is 1/3. The slope of the origin to C is up 3 and over 1. Now, I forgot on my counting for A that I had to go down 1, so it's a negative 1/3. And remember, those two slopes are perpendicular to each other because they're the negative reciprocal, and perpendicular lines are 90-degree angles. So I know that that's definitely a 90-degree angle. On the other part of it, if I look from B to the origin, and I do its corresponding D to the origin, and again, I look at these slopes. B slope was a negative 3 because I went up 3 and over 1. The D slope was up 1 and over 3, which is 1/3. Once again, those are perpendicular, so that's also a 90-degree angle. So my answer to this would be yes, it is a rotation, and it is a 90-degree rotation. Now, we haven't dealt with finding angles of other sizes other than 90, 180, 270, 360. So those are the ones I would expect you to be able to do. I might expect you to recognize other degree angles like you'll see on the worksheet, but there'll be clear distinction between the different sizes of the angles. So over here on B, or the second graph, if I look at from A to C right here, well, I connect my little pins off a little bit. There's my line from A to C, and there's my line from there. That's kind of a little tiny angle. If I go look at going from D and B, here's my angle here, and here's my angle here. Now on my other angle, the slopes aren't really going to be the same. I was basically going On one of them, it was a slope of 1, 1, and the other slope was a slope of undefined. So I can't really tell my size of my angle from that. I just know it's a smaller angle. And if you'll notice, this purple line was a vertical line, and over here, they're not a vertical line, either one of them. So my two slopes are not my slopes, but my two angles are not the same size. As you can kind of see on the green line, I covered up the pink line from C to D, but on the purple line, it went out more. From A, it was a vertical line, and to B, it was not. So therefore, those two angles are not the same size, so this one is not a rotation. Okay, we're going to talk about rotations. There are 3 ways of doing them. Patty paper, which you can ask your teacher about in class. I'm now going to show using the rules and how to find the rules if you can't remember them. And then I'm going to show another method that also works as well. So I'm going to give you 2 different methods on the video, and your teacher can show you a third method. Rotations tend to be the hardest one for students to see. So first of all, you'll notice that this says counterclockwise, and our book says every problem is going to be done in counterclockwise format. Now that's not always true, so on our worksheet we did say clockwise or counterclockwise. If it doesn't ever say which way to go, then go counterclockwise. First of all, I'm going to talk about turning 90 degrees would be like taking my paper and turning it sideways. If I want to go 180, it's like turning my paper upside down because I have to go 2 turns. If I talk about 270, I have to go 3 turns. And then if I talk about 360, I've gone all the way around. I turn my paper around. So I am a visual person sometimes on seeing these. So I'm going to actually do that. I'm going to, first of all, write the coordinates of the point that I have on the paper, which is at 2, 3. I went to the right 2, and then I went up 3 to get to my point. So now I'm going to take and I'm going to turn my paper 90 degrees, counterclockwise. There we go, line it up, so it's 90 degrees. So now I'm just going to look at my thing. Where's my new point at? Well, I went to the left 3 and I went up 2, so my new point is at -3, 2. So I'm going to turn my paper back around, and I'm going to write my new point at, put my pen on, I ended up at -3, 2. Notice my rule. It said I took the x and y's and I flipped them around and I changed the sign on the y value. That is my 90-degree rotation counterclockwise. Now, if you kind of stop and think about it for a minute, if I am going 90 degrees counterclockwise, then if I go clockwise, that would be a 1, 2, 3 turn, and I'd end up at the same location. So a 90 degrees counterclockwise actually turns out to be a 270 degrees clockwise. Okay, so let's look at the 180 turn. Our point was at 2, 3. I'm going to take my paper and I'm going to turn it 2 times so it's upside down. 90 degrees. One more turn to get it to be 180 degrees. And where are my new coordinates at? Well, this time I'm going to the left 2 and then I'm going down 3. So that would make it a -2, -3. So I'm going to take my paper now and turn it back around so that I can write on it. So my new coordinates are at -2, -3, just like my rule says. I take the x's and I take the y's and I change the sign. Now I can continue to do the same process for the 271. So I'm going to do kind of the 270 and the 360, and then I'm going to go write them back down. So I'm going to take my paper and I'm going to turn it 270 times. So counterclockwise, that would be 90. Upside down is 180. One more turn. That is my 270. Where is my new point at? It's at +3, -2. If I continue to turn it, I've now gone 360 back to what I started with, and my coordinate is back to the 2, 3 point. So when I go 360, it doesn't change it. Now let's go back to the 270. What if I went 90 degrees clockwise? That is exactly the same thing. So I can see that that relationship goes. What if I went 180 clockwise? Oh, look, I'm upside down again, just like I was when I went 180 counterclockwise. So now let me turn my paper around. So, to write down what we just did, when we went counterclockwise 270, our point 23 went to 3, -2, and our point 23, when we went 360, went right back to 23. So 360 is going all the way around. Now on the 180 degrees, it doesn't matter if I go clockwise or counterclockwise. So this 180, this rule is the same for counterclockwise as it is for clockwise. On the 270 degrees, the rule matches up to a 90-degree clockwise turn. So you kind of want to see that relationship there. And 360, you're just right back where you started. Okay, so now I'm going to talk about a visual way of doing it. The one thing you have to realize on the visual way is notice on my 90 and my 270, what happened to my points? They flipped. So I have to recognize that on a 90 and a 270, I have to flip the points around. 2, 3, 3, 2. 2, 3, 3, 2. On the 180 and the 360, I don't flip them. Of course, 360, I don't really do anything. So I'm going to talk about my coordinate system. If I am in the first quadrant, every single sign is positive, positive. If I am in the second quadrant, I'm going to the left, which is negative, but then I go up, which is positive. If I'm in the third quadrant, I go left, negative, and down, which is negative. And if I'm in the fourth quadrant, I end up going right, positive, and down for negatives. So this is another way to do it visually without actually turning your paper if you don't want to, or learning the rules. My answers, if my point ends up in the second quadrant, it's going to be negative and a positive. If it ends up in the third quadrant, it's going to be negative, negative. And then if it ends up in the fourth quadrant, positive, negative, etc. So remember that if I go one turn, if I go from one quadrant to the other quadrant, doesn't matter which quadrant I start at, if I go from one quadrant to the other quadrant, that is a 90-degree turn. If I go from one quadrant to 2 quadrants over, that is a 180-degree turn. If I go from one quadrant, 1, 2, 3 quadrants over, that is a 270-degree turn. And then if I go all the way back around, I end up right where I started. So that's 360. So visually, if I'm going to do a 90-degree turn, what that says is I'm going to take this point and I'm going to move it one place. So that means I'm in the second quadrant. Because it was 90, I have to flip the numbers, 3, 2. And because I'm in the second quadrant, it says the first numbers is always negative and the second number is always positive. If I take that same point and I go and I want to get it over here to this quadrant, that's 2 turns, which is 180. I don't flip my points, so they stay 2, 3. But that quadrant that I landed in is a negative, negative. If I go to 70, which would be 3 turns, and I end up over here in this quadrant, I have to flip my numbers around. So it's 3, 2, and then I have to look, what are my signs in that quadrant that I ended up with? Positive, negative. So my points could start in any quadrant. And when I start in any quadrant, then it gets me around to the other ones, and I look at, okay, what quadrant did I land in? That's my signs. If it's 90, I flip the order of the numbers. If it's 270, I flip the order of the numbers. If it's 180, I don't flip the order of the numbers. So that is the visual way of doing this without having to memorize your rules. Okay, we're going to do an example for rotations now about rotating figure with the coordinate rules, only I'm going to probably do it by the visual method instead. If you want to do it with the coordinate rules, just pause the video, do it, and see if you end up with the correct answer. So first thing I'm going to do is plot RSTU, so pause your video and you plot those as well. Okay, I stopped. I plotted my 4 points. Now I'm just going to give you a visual of what happened. So I'm going to take my paper. I'm going to turn it 270 degrees. That shows me where I need my answer to be. So $90, upside down 180, all the way around one more time is 270. Notice where my quadrant is. It's in quadrants 3, and then it's in quadrant 4. So when I do my graph, notice it's over here in 3 and 4. So that's where I want my graph to end up with when I'm done. I'm going to turn it back around and actually do the plotting. So there we go, back to right side up. Now I'm going to take my points, and I believe in writing the coordinates down, so I'm going to go over here to the side and I'm going to write R prime, S prime, T prime, U prime. Now remember, I want to go 270 degrees, so I'm in the first quadrant. 1, 2, 3. So that means when I do my points that are R and S, because they're in the first quadrant, I need to think about what are my signs in the first quadrant. In the fourth quadrant. That's where it moved to. My signs down there is I go positive and I go negative. So I know that these both have to have a negative answer. And then remember, 90s and 270s, you have to flip the points. So R was 3, 1, I got to flip it to 1, and then it'll be a negative 3. S was at 5, 1, I have to flip it, so it's going to be 1 and negative 5. Now, if I look at my T and my U, they are not in quadrant 1, they are actually in quadrant 4. So when I take and move it, 1, 90, 2, 180, 3, 270, I have to end up in the third quadrant. Remember when we turned our paper over, we knew our answer had to end up in the third quadrant. So when I do that, my third quadrant signs are negative, negative. So that means my answer has to be negative, negative. Just ignore my little blue mark over there. And then again, it's a 270 turn, so I have to turn it around. So this becomes 3, and that becomes 5. And then on my U, a 1, and then a 2. So I look at where they land. I don't really pay attention to the signs. So now I have my coordinates, so now I can graph it. At 1, I'm at a negative 3. That is R prime. At S, I'm at 1, negative 5, which is my S prime. At T, I'm at negative 3, negative 5, so that is my T prime. And then finally at U, I'm at negative 1, 2, that is my U prime. So when I rotated my figure, it went to right there. So rotations are not that difficult, you just probably need to practice. Okay, so now my rotational theorem. Remember, we had it for reflections, we had it for translations, and now we have it for rotations. And that is, a rotation is an isometry. Remember, basically what it means to be an isometry is just that the two figures are congruent. They held their size, they held their shape. So I'm going to look at this first example. The quadrilateral is rotated about P. What is the value of Y? So what I want to do when I'm finding this problem is I want to see what corresponds. So here's my Y. Oh, look, there's my other Y. So I'm going to write an equation with that because they have to be the same size. So 7Y has to equal 4X plus 1. Oh, how do I solve something that has two variables? Well, we can't do that unless we have a second equation. But guess what? We really don't have to do systems. So I'm going to go look over here at my problem again. And I'm going to say, okay, do I see any other two sides that correspond that have something on it? Well, the side that has 19, there is nothing corresponding. But if I look over here at the 3x, it corresponds to the 15. So that equation would be 3x equals 15. Therefore, x is 5. Now that I know what x is, I can go over here to this equation and replace the x with being a 5. So I have 7y equals 4 times 5 plus 1. So I get 7y equals 4 times 5 is 20 plus 1. 20 plus 1 is 21. 21 divided by 7 is 3. So y is 3. Be very careful that you finish the problem because remember over here it had a 5 as a choice, but that was not the right answer. Have a great evening. I hope you enjoy these rotations.